Hello learners and welcome to your natural sciences lesson. So in this lesson we're going to be looking in detail at what resistors are. But before we begin, did you know that resistance causes some of the electrical energy to turn into heat? So the heat that we feel whenever we switch on our heater, it is because of the resistance. So in this lesson we're going to be looking, as I've said, we're going to be looking at resistors in more detail. But before we get to that point, we then need to now make certain goals that we need to achieve by the end of the lesson. And the goals that we are making are as follows. So by the end of the lesson, you should be able to, number one, explain that conductors heat up when current passes through them. Number two, explain that some energy is lost or wasted from conductors as they heat. So when conductors heat up, they are basically losing energy or they are wasting energy. You also need to be able to describe what a resistor is, and then list uses of resistors, and then lastly, discuss 4 factors that affect resistance in a circuit. So these are the goals that you are setting just between the two of us so that we can be able to achieve them by the end of the lesson. But then, what is going to help us now to achieve those goals is to look at our main idea, being the uses of resistors, and break it into small concepts, whereby we're going to start by looking at conductors of electricity, and then after, look at what resistance is, and then lastly, look at the factors that are affecting the resistance that you're going to be talking about. So, things that you already know by now, whether in relation to the resistance or electricity in general, is that electric cells and batteries are a source of energy and are used to power electrical appliances. So the electric cells and batteries are the source of energy and we use them to power up our electrical appliances. Then we also know that when 2 or more cells are connected to one another, they form a battery. So more than one cell forms a battery, but if it's just one cell, it's just a cell. And then cells may be connected to one another in different ways in order to form a battery. So we can connect our cells either in series or connect them in parallel. However, remember that the output energy that we received from both of those 2 connections is going to be different. So in series, we're going to receive a much more greater output as compared to when the cells are connected in parallel. However, when your cells are connected in parallel, you need to remember that they are going to last longer. Then with what we know, can we then be able to answer this question? We are asked to draw an electric circuit that has 3 resistors that are connected in parallel. We're also going to have a battery that is consisting of 4 cells. Now, the main thing here is that the resistors are connected in parallel. Remember, if your resistors are connected in parallel, that means the current or the current flow has more than one path to take. And in this case, it's going to be 3 different paths that the current can be taking. So we're going to start off with our battery consisting of 4 cells. Remember, this is just the one cell. This is just the one cell that consists of a positive terminal and a negative terminal. If I connect another positive and a negative terminal, that makes up a battery. However, this battery will have 2 cells. And the question says 4 cells. So this is going to be 2, 3, and 4. So I have 4 cells now that are consisted in this battery. And now I need my 3 resistors. Remember, my resistors must be connected in parallel. That means there needs to be more than one path taken by the resistors or by the current flow as it is moving from one point to the other. So these are going to be my resistors that are connected in parallel. My resistors connected in parallel. We can also add a closed switch. We can also add a switch onto this electric circuit. A closed switch tells us that there is current flow. This is you switching on the light now. Remember, current, it is moving. Once it gets to this point here, it needs to divide proportionally. That means if we are to label our resistors as R1, R2, R3, when it gets to this point, it's going to divide proportionally, meaning that the resistor with the highest resistance is going to receive the less current. So when this current divides, more of this current is going to go to the resistor that has the least resistance. For instance, if this is 2, this is 4, and this is 6 ohms each, the current is going, more of the current is going to go to the 2 ohm resistor, because there at 1 ohm there is less resistance. There's less resistance to the flow of current. However, in the 6 ohm resistor, there's going to be less current passing through there, because there's more resistance of current to flow. So therefore, current divides proportionally in terms of the resistance that you find in each of those resistors. But still, current will be passing through all of those resistors. And now, with that said, when we are moving on, there are certain words that you're going to be using throughout this lesson to better explain the main idea being the resistors. We're going to be making use of words such as battery, electric cell, delocalized, and then also we're going to be making use of words such as resistor, a rheostat, and a conductor. So these words are going to be used to better explain the main idea being the resistor. So before we start with the first concept, we're just going to go for a quick short break, and I will see you just after this.